Hi, everyone. Good morning, good afternoon, good evening, wherever you are joining us. And here we are coming here with another set of talk. And it's a very interesting and a different talk. Here we are talking about smart contracts and securing it with AI. Now, AI is the talk of the town, and automation is the key behind it. So, let's hear from Shashank, who has a lot to share about different aspects around smart contracts and AI and security. Hello, Shashank.
Hey, hi, Vanna. How are you?
I'm good. So let's get started with your talk, and the stage is all yours. We want to know more about it.
Sure. Hey, everyone watching this, stream. Today I will be talking about scaling smart contract security with AI and automation. It's like if you, I'll just give you a brief. What things we'll cover. The first thing would be it's like my introduction. Then we'll talk about why smart contract security is important. Then we'll talk about the problem statement. The problem statement is, it's like scaling of smart contract, it's like security. Then we will, do a, it's like case study of a real hack. And on the fifth step, it's like we'll figure out how we can, it's like protect those hacks from happening using automation. The next would be it's like we'll see through the problems of automation and limitation of automation. And then we'll also talk about it's like how we can solve those limitations and reduce those limitations using AI, which is the main topic. And at the end, just contact information. So we'll get started. I'll give a it's like small introduction about myself. I'm currently it's like the CEO of Credit Shields, which is a Web3 cybersecurity company where we are building Solidity Scan, which is an AI powered cloud based smart contract security scanner. About my past experience, I've been it's like I've been into security for past 12 years, starting at a very young age of 14 when I found my first bug in 2013 in Google, which was a cross-site shifting vulnerability, and that pushed me to do more bug bounties. I discovered bugs in it's like Facebook, Microsoft. I have 30 days in Apple iOS 10.3 with a CV assigned to me, and I've conducted 400 plus pen tests in these tenure. My professional work, I have worked as a security engineer at Deriv while I was doing my BTech. After my graduation, I joined HackerOne as a security analyst. And 4 years back, it's like I got into Web3 security while I was working for a Web3 company called Avalanche. And then later on, I started my own company. So this is, a short description about me. Let's begin the talk. So why security automation? So if it's like if we revisit the data of hacks last year, around 1.58 billion dollars were lost in it's like blockchain related hacks. And it's like the data says like 55% of them were directly related to smart contract vulnerabilities. So it's like out of it's like 1.5 billion, that sums are around 700 million. The 700 million was lost to hackers because the smart contract had certain vulnerabilities in it, which was exploited by a malicious hacker. And it's like and the money was gone. So the problem with the current industry is it's like we are heavily relying just on it's like manual services, although manual services is really good. But then it's not scalable as this industry is also growing. So it's like in this talk we'll see how we it's like use automations to find security vulnerabilities in smart contracts and then enhance its capability using AI. This is a it's like a simple graph. If you see it's like there were total 420 hacks, which amounted to 1.5 billion dollars. If you're more interested, you can go to the link and then see it's like the categories of hacks which has happened. So yes, let's talk about problem and solutions. So the problem here is the rising financial losses. The problem with smart contracts hack is it's not just data loss; it's direct financial loss. People lose Bitcoin, Ethereum, whatever. People lose real money in there. And the second problem is heavily relying on manual auditing is it's like it's not scalable. Uh, there are times during bull run when it's like auditing companies are like they have a backlog of 5 months or 4 months. It's happened in 2022 and 2021. So it's like security gets rushed because it's like there are less people, and it's like it has not been scaled yet. The solution is automation. Obviously, automation can remove like 70-80% of the vulnerabilities, which it's like reduces overall it's like manual audit hours, and hence it's like it increases the scalability of security. But our algorithmic detectors have limitations. It's like they spit out a lot of false positives, they miss edge cases, etc. And that's where AI comes into picture, because AI has context, and hence it's like it can find better vulnerabilities when mixed with algorithmic coding. So, how I'm going to present this, is first we'll talk about one real hack which happened. We'll understand how that hack happened, and then we'll write an automation for that. Not write, basically, I'll show an automation. It's like how using automation those vulnerabilities can be found, and then in the last step we'll show it's like how AI can enhance those detections. So, taking as a case study, this is actually a real hack which happened on 2nd September 2022. So there was a ShadowFi smart contract which was exploited for $316,000 due to an access control vulnerability. Now, why I picked access control vulnerability as an example is because, for example, it's like if you talk about Web 2 as well, it is pretty easy to automate, cross-site scripting related vulnerabilities, SQL injection related vulnerabilities, because it doesn't require a lot of context. It's like there is an error or it is being reflected in the body, you flag it. But it's like even in Web 2, automation of access control vulnerabilities has been difficult because it relies on business logic, and hence the automation detectors needs to have context. So it's like access control vulnerabilities are also present in smart contracts, and that's the reason I'm picking this up as a case study. So we'll start. So this is it's like if you see the image, this is basically this is basically the transaction flow of the hacker, which it's like we decoded to figure out how the hack happened. So if you see it's like the first transaction, in what happens in the first transaction is it's like someone tried to buy wrapped BNB, which is it's like Binance coin. Then using that Binance coin, this was done because this hack happened on Binance chain. If you see the second and third, the hacker tried to like buy some small amount of ShadowFi token, which was the ShadowFi contracts native token. So you can see the hacker bought it's like bought 9 ShadowFi tokens for it's like very small price of with a very small price of few cents. Okay. And then something interesting happened. You can see it's like the official contract is sending almost 10 million tokens to null address. So let me explain what a null address is. So in blockchain, since it is immutable, if you create anything it's like it's not, it cannot be destroyed, it remains in the blockchain state. So to address this problem, what is like what is a known method is that, for example, you created 1 million tokens and now you want to destroy it. So since there is no way to delete it, what you can do is you can send it to null address, which is a zero address. And since nobody has control of the zero address, the tokens is considered as burnt or maybe dead. So the attacker actually managed to send 10 million ShadowFi tokens to a dead address, burning majority of the total supply. And we'll come to this. It's like this is where the vulnerability was, which was exploited. And what happened, it's like if you notice, then the malicious hacker, what he did was he sold it's like 9 ShadowFi tokens at a very high value of $316,000. So how it's like tokenomics work in most cases is it's a demand and supply problem. It's just like our day-to-day thing. Like for example, if the price of onion goes up in the market, the reason behind that is maybe because the supply is low and the demand is more. So what the hacker did here was, by destroying 10 million tokens, he it's like he or she it's like managed to raise the price, because now the amount of tokens were less, and hence the price went up. And he was it's like owning 9 tokens, which from cents went to the value of $316,000. And it's like the hacker sold it for the wrapped BNB and cashed out the money. So this is one classic it's like hack which happened. And our main focus would be, why was the attacker how did the attacker manage to it's like it's like do this, burn the token supply, where he or she was not the admin. So for that, we need to look into the code. So if you see it's like if you see the code here, it's like let me show you. So if I show you the code, line number 962, 962, 962. So you can see it's like there is a burn function. As I mentioned, it transfers from it transfers the amount to the dead address, and then it's like emits that okay, the token has been burned. So what we can notice it from here is, this is a public function, and there is no access control in place. So ideally, what should have happened was, there should have been a modifier here, which restricts this action to the admin only. But since the function was completely public, anyone, even the hacker or anyone, could just like call this function and burn the token supply, and hence raise the token price. So this was the actual it's like vulnerability, which it's like which was exploited. But it's like and actually the fact is, this is a very common vulnerability. If you see our it's like this slide, access control, there were 26 cases related, like out of the 420 hacks, 26 cases were related to access control vulnerabilities, where there was improper access control, and that led to a hack. Now it's like if we approach it, like how would we write an automation for that? So for that, I need to explain it's like how access controls are protected. It's like how access controls are implemented in it's like in smart contracts. So there is something called it's like a modifier in smart contracts, which is added, which is a common way of adding it's like access control on a particular function. For example, if we see this example, the update owner function has this modifier only owner. So I want to explain it's like how this it's like code works. So whenever you call this function update owner, it won't it's like run these queries first, like setting the new owner. The first thing it will do is, since it has called a modifier, before running these statements, the compiler will first check this. So the only owner modifier says that the message dot sender, which means the person who is calling the function is owner or not. And if it satisfies, then this symbol actually tells the compiler that you can go ahead and execute the rest of the function. But if this fails, this will revert, and hence this function will never be called. So if I remove only owner from here, what will happen is anyone can call this. But if I have this only owner in place, then it's like it will check who is calling the function. So if we see the code, it's like if we see the code of the Shadowfi, let me it's like put it in a one second. So if we see, they did have it's like only owner. So they did have this modifier in place, but what happened was, they forgot in the burn function. So if you see the burn function, this public only owner was missing. So this is a it's like a classic mistake, where it's like and kind of a very simple mistake what developers it's like make, they forget the modifiers, or they forget to add, it's like any other restrictions. And see, the loss was $316,000, which is a very big amount. So this was the actual vulnerability in the code. Now, it's like, if you talk about automation, how we can automate this. So the basic logic behind the algorithmic coding for finding these vulnerabilities in an automated fashion would be to check if, it's like, only owner modifier was present, and if, it's like the important function is missing it. So that is one way. So if we do that, you can see, it's like, using automation, we can actually detect that, okay, this function is missing access control. But there is a problem with that. So the problems with, the limitations is, you can see, it's like, if we write an automation for that, the automation detected 24 such cases where only one was valid, because other functions did either had some sort of access control, or didn't require it. But the problem with algorithmic coding is, you write, it's like, if else statements, it's like conditions, logics, etc. But those logic never have the context of each, smart contract, and hence, it's like, the logic can miss. And this is a, it's like classic example where 20 out of 24, only one was valid, and there were 23 false positives. So the problem with simple detectors is that, it misses edge cases. It doesn't understand the concept of rbacks, or, it's like, there is a custom rback. Even if we, it's like, feed in, most popular rbacks, it will miss custom rbacks or custom, it's like, checks. For example, if this code is there, this is one classic way of doing that. So if this is missed, like, if only owner is missed, the automation can, detect it. But what if, it's like, someone goes with a custom, it's like a require statement, maybe require message dot sender is equal to owner, for example. It's like this, if there is, it's like a custom check, it's like, instead of, going for the popular route, then again what will happen is, your automation will check, oh, there is no only owner, so this will be flagged. But the fact is, there is a protection in place. So how do we tackle these issues? This is the problem with automation, algorithm, and this is where AI comes into picture. So if we, it's like, talk about AI, the advantages of AI is, it has contextual, and it can do contextual analysis and and contract behavior. It can understand the behavior of the contract, and hence, it's like, if there is a context, and then you run, it's like, algorithmic coding along with AI, it will give you better results. Again, AI can understand role-based access controls. If you feed in the entire, it's like, contract to an LLM, uh, the machine learning trait, it's like, models can actually understand, it's like, if there is an RBAC in place, if there is a custom RBAC in place, and then, it's like, based on that, it's like, we can reduce false positives, or, enhance detections. The third thing is, it's like, continuous learning and adaptation. So for example, every time it's like, you detect a false positive which was missed by the AI, it can be fed back to the system again. And over the period of time, this also improves, because, unlike traditional algorithmic coding, LLMs can learn, it's like, it can be trained to be better. So these are, it's like, using these three advantages of AI, we'll see how false positives are reduced for the same case, like same automation of the same contract. So let's go. So, it's like, if you see this icon, this is basically, flagged by the AI that this is false positive. So for example, for the burn function, which was actually a bug, the automation tool says that, okay, it's like, this appears to be a valid result. And you can see, out of the 24, many of them has been marked as false positive by the AI, because a context of the code was provided. Let's see another example where it detected a false positive. So you can see, it's like, there was a function which was previously flagged as valid bug, was later on, it's like, when passed through the AI, it was said that, okay, this appears to be incorrect, which makes sense, because you can see, it's like, there is actually a custom, permission check available. So authorized for permission adjust dot contract variables. So because it's like now, before going for the algorithmic coding, the AI parsed the entire code, read the rbacks, and then found that okay, there is something like custom check of permissions, and that has been implemented in few functions, and hence we can see it's like the AI tells that okay, this decision may be incorrect. So if we talk about the results, without AI, there were 24 detections, valid was one, and false positives were 23. Again, in a very traditional way, this is still helpful because it's like the user or the developer or the company were able to catch a very big vulnerability at a click of a button. But then it comes with a lot of inconveniences that there were 23 false positive detections. With AI, you can see it's like it removed 19 of the false positives, so the number of false positives were still 4, and the valid one was not a false negative, so it was still found as valid. So if you see, like, we had 19 fewer cases, the AI itself reduced 19 false positives. So as a developer or a company or a user, it's more beneficial for me to it's like read through 5 bugs than 24 bugs in which only one is valid. So the percentage of reduction was a drastic change, which is 82.6%. And it's like this is how providing context to the AI, we can actually make detections better. The problem with even with the it's like in like 5-6 years back when we talk about web 2 tools, there was always a concern that automation tools cannot detect business logic vulnerabilities, or it's like bugs that required context, access control, etc. But with the on-bringing of AI, now it's like any algorithmic coding will also have a context, and those contexts can be used to make the detections better and hence reduce the false positives. And if you reduce the false positives, scaling becomes much easier because less time would be spent on false positive bugs and more time would be spent it's like on it's like valid detections, and hence overall there is an enhancement in scaling of security. So this is all about my talk. I would also like to say, it's like we have launched this in collaboration with OWASP, um, uh, smart contract security verification standards. The blockchain security is way behind in terms of security and standards, and hence it's like this is an open source project with OWASP. Anyone can contribute to it, and we are trying to set like standards for smart contract security, um, to help industries understand what kind of vulnerabilities are there, how they can maintain a checklist, how they can ensure it's like automation and everything. Last but not the least, if you would like to connect me over it's like Twitter or LinkedIn, and if you wish to talk about Web3 security or anything, would love to do that. I really love to hear ideas and questions. This also helps me to learn. Thank you so much.
Thank you so much, Shashank. I think it was wonderful session. A lot of people would reach out to you to know more about the topic and the way we are fixing the false positive in smart contracts. So thank you so much for joining us today.
Thank you.